Hello everyone, welcome to today's session on physics by Stutors for class 11th. So before going to the video, subscribe our channel if you haven't done that yet. Also enable the bell icon to get daily notifications. So next we have the second branch of calculus, the integral calculus. So integral calculus is actually for defining and calculating the area of the region bounded by the graph of the functions. So we know that what was differentiation mainly for? It was actually for finding the slope. Here it's actually for finding the graph, area of the graph. Yeah. So first differentiation was for finding the slope of the graph, and integration is mainly for finding the area under the graph. So and an integral calculus is also called as antiderivative. Yes, it's more or less this is just exact opposite of what you do for differentiation, and you will realize it soon. Yes. So yeah. So just having a look at how it actually comes. Imagine we have a graph like this. Yeah, we have a graph like this, and we need to find the area below this graph. So it's quite simple because it's a straight line. We join, we join those points, the end points with the x-axis, and we have a rectangle, and we now know that it's this point is B, this point is A. So we know that the area will be length into breadth, B minus A into f of x. So if B minus A is delta x, f of x into delta x. Okay, that's quite simple. The area is quite simple for this kind of a graph. Whereas if the graph is of this kind, if it's not a straight line, you can't actually multiply the length and breadth and find the area. No, we can't, right? So here mainly because we have curved section here, so we can't multiply it that way, because then it will be more of like this, and we actually find it using the same formula as of that of the straight line. So what we do is we make this region into small rectangles. We slice them into small rectangles like this which is already here. So it has a very small breadth and more or less a straight line. So we can apply the rectangle rule here. So the area of the small rectangle, delta area, we write as delta area since it is very small, is, let's take this length as delta x, and this height is obviously f of x. So next what we need to do is we are summing up all of these rectangles. We have many rectangles like this, right? So we are just summing up together so that we get the full area. So you might be familiar with this kind of a symbol. Yes, it's the summation symbol. So we have delta A, and we have delta A, and we are combining all the delta A's to find the total area. So delta A, we know that its delta is f of x. So we are just summing it up, and this summation is also called as this integration. Here we know, here we are actually finding the area of the curve between A and B. So from A to B, integral f of x dx will give you the area under this graph. Okay, so that's since we have 2 points A and B given, we have a definite area, right? So it's called as a definite integral, and you can find the definite value and find the area. So I already told you, integral are actually antiderivatives. So this is why I actually told you that, because um, here we already know this. We already know this part, right? Yes, we already know this part. So we have x power n in the RHS. So when we integrate x power n dx, we get x power n plus 1 by n plus 1. And we have a plus c here because it's not definite integral. So I'll explain to you why we have a plus c here, because imagine we have a function x square. We have a function x square, and you know that the derivative of this function is 2x. Okay. But now imagine imagine if the function was 2x square plus 7. Still you have the same derivative, right? So imagine if the function was just x square plus c. Still you have the derivative 2x. So you are finding the antiderivative of this 2x. So you are finding antiderivative of 2x. So I told you it's integral 2x dx. So by this equation, which you need to study, here n is 1. So similar to differentiation, you can take the always take the constants outside. So 2 into integral x dx will give you 2 into x square by 2 plus c. So now we know this c is actually this c. That c can be any value. It can be 0. It can be any values. Whatever be the value, the derivative is always going to be 2x. So that's why we have a c there. So similar to differentiation, you have a set of formulas and equations which you are expected to learn. And yeah, you have something here. We know that d by dx of 1, d by dx of x is 1, because x to the power 1, and you have 1 into x to the power 1 minus 1, and it's 1. Yes. So integral of dx is actually x plus c. So here it's actually integral x to the power 0 dx. So you have x to the power 0 plus 1 whole divided by 0 plus 1 plus c. So that's x plus c. Yes, that's the answer here. So once you're clear about, once you know this very clearly, then it's quite easy for you to derive the integrals of all the polynomials except for x power minus 1, because when n is minus 1, you will have 0 in the denominator, so again which is infinity. So in that case you have a different answer, or for all the other case you can find using this. Okay, now again you have derivatives and antiderivatives. We have a comparison table, so this might help you to by heart it, because you have a pattern here. Derivative of sin x is cos x, and derivative of sin x is cos x, and integral of cos x is sin x. Okay, so it's just like the opposite. You are giving a function, you are finding the derivative, and you are finding the integral of the derivative, you get back the function. Okay, it's that simple. So once you know all of this, automatically you learn all of this too. So it's better if you can learn the derivatives of all those trigonometric functions. Later on you will also learn, here now we don't know what is integral of tan x. So you'll be learning it later in your class 12th integrals chapter. So I would recommend you to make a table of these data also and have it ready made on your study table so that you will have a look at it every day. So we are coming at the end of our video today. So let's see what are some of the applications of integration. You have so much of applications for integration. For example, yeah, you might have learned that work is force into displacement, right? So imagine you have force and displacement, a plot of force and displacement, and you have a graph something like this. So you know that work is F, force into displacement. So it's more or less like the area under the graph. But since the graph is curved, you can't find it directly multiplying F into X. So here we use this integral. If you need to find the work done between A and B, and X is equal to A and X is equal to B, you just write integral A to B F. F will be, F is a function of X, so we can write F of X, and yeah, and we know, we have already seen this. We actually slice it into different smaller rectangles with breadth dx. So we write here dx. So this is the length, this is the breadth, and you hence find the area. And here in this case, that will be equal to the work done. Okay, so another application is to find. See, for example, you have a long road, iron road like this, and you know the linear density is something like sigma. So this means that if you have a very small unit of length, a dl, and the total length is l, okay. So for dl, and the linear density is actually total mass by total length. So you know there is some value for sigma, and you know that for dl, yes, for when you yes, you actually need to find out what is the mass of this small area, small portion of the road. So when you multiply dl with sigma, you get the mass of this small portion. And if you want to find out the mass of this entire road, you can integrate it between 0 and l. Since the length of the road is l, you integrate between 0 and l, and you get you integrate 0 and uh, integrate 0 to l sigma dl. So yes, you can find the total mass of the road using this. And there are quite many other applications in many of your chemistry and physics derivations of different phenomena explained using this calculus. You will have to use this integration and differentiation. So it would be well and good if you know this now itself, because right from the second chapter of physics you have the application of differentiation and integration, whereas you learn this in mathematics only at the end of the only the beginning of the second textbook, I guess, and which is the irony here. So it's better if you know this now itself. And I would also like to recommend to work out certain problems, especially for differentiation. And I will mention the exercise number in the description box. So it's always better if you could work out some of those questions so that you'll be thorough with differentiation. And it is going to certainly help you for the entrance as well as your board exams. So hope you all understood this topic, and if there are any more doubts or suggestions, please drop them in the comment box. Thank you.